festive.
Yeah, that's why I was at prime time.
Yeah, prime time.
Hi, my name is Siri, and I will be guiding you through this tech talk. This semester, AH4 was asked to design a robot that would play air hockey autonomously, meaning that once the start button was pressed, the robot would use a PlayStation 3 camera to track the puck, block, and return any incoming shots. We decided to use a dual rotary design. This means that two motors were used. One would control the shoulder joint, the other would operate the elbow joint. The motors we decided to use were the fastest out of all the other groups. They were so fast that we had to use a gearing ratio to slow it down. Doing this gave us greater accuracy with our vision software, so we were able to track the puck on the order of a few millimeters. Since the motors we used are much larger than any of the other teams, our robot had to be much larger and use a more hefty construction. As you can see, this did hinder our performance at some times. The camera would lose the puck if it crossed underneath the arm or got stuck in a corner. These are the times you see Connor hand the puck back to the referee to give the puck to the other team. To start our build process, we ran a simulation within MATLAB that would determine the optimal arm lengths for our robot. With this tool, we were able to have a much greater reach than any of the other teams while staying within the allowed table boundaries. Therefore, our robot was more similar to a human's arm because the lengths of the two arms were relatively the same. This allowed us to hit the puck with a lot greater speed because of the increase in angular torque. Another design challenge we had to face was that the robot had to be mobile. This is why we spent more time and money using mostly aluminum and wood construction, because those two materials offered us the best strength-to-weight ratio. In addition, every electrical connection had to be soldered to ensure that the vibrations caused from movement and gameplay wouldn't short our system. Here you can see the live output of the camera. Many pieces of processing are going on here within the OpenCV library in C++. Each frame is instantaneously being processed using filtering, dilation and erosion to only focus on the green content and remove any noise. Doing so allows the puck only to be seen, since the camera is mounted on an angle to the air hockey table, so we had to use homography to convert the skewed image into a proper rectangle, giving us exact pixel locations of the puck, and that's how the motors can in turn move to that puck position. If you are wondering, we didn't win. Here are the last few moments before we lost in the Final Four round. My name is Siri, and I hope you enjoyed today's Tech Talk.